Congratulations on making it to the final video. Thanks for sticking with me. Your perseverance is going to pay off because in this video, we're finally going to talk about basic image recognition. We're going to capture information from the screen and use it to inform our bot's actions. Hey, it's Ben, and this is Learn Code by Gaming. In this video, we're going to learn how to use PyAutoGUI's screenshot functions to figure out what's going on inside the game. That way we can use information from the screen to figure out how our bot should behave. If you haven't seen the previous videos in this series, there's a link to the full playlist in the description. So today, we're going to close the loop. This is the last piece we need to complete our trading route so that our bot can run completely automated. What we'll end up with is a very primitive artificial intelligence, but these first steps are what everything else can build off of.
Okay, so at this point our bot can do almost a full trading loop. The one problem we still have is when we enter a station, we start at a random location and we want to go from there to our starting position, and right now we have to do that manually. So your character should be just docking at Loki Station after coming back from Earth Station, since we automated that portion. And when we land here, we're going to start at one of a number of different possible starting positions. So I think in a previous video I thought there was maybe 4 starting positions, but after going through this I think there's more like 20, maybe even a little bit more than 20 possible starting positions. And what we want to do today is we want to try to figure out when we load into a station, where exactly is our character, and then once we figure out where our character is, we want to write action scripts that go from this starting location to our universal starting location, which here in Loki Station is against this wall talking to Loudon McEwen. So the way we're going to do this is we're going to use PyAutoGUI's screenshot functions to figure out when we load in here what position we're at. So what we'll need to do is we'll take a screenshot of each one of these positions, and then from that screenshot we're going to crop out just a small tiny portion of that image, and we want to get a portion of that image that's unique to just that starting location, but that also isn't going to change every time we're at this starting position. So for example, right now there's some things moving in our image and there's some things that aren't. So a bad screenshot to take, or a bad portion of the screenshot to crop to, would be this section at top above the doorway where we have this gold emblem that's spinning around. That's not constant, so we won't be able to match a image to that position consistently. We want something that's going to be the same exact pixels every time we land at this same exact starting location. So generally I'm going to take a screenshot of something in the background, something without any lighting effects, and that should stay consistent in between each time we land at the station. And then once we have those images to help us figure out where we're at, we're going to record actions to get from this location to our universal starting location. So to accomplish this, PyAutoGUI uses Pillow. Pillow is the Python image library, and it should be installed already when you installed PyAutoGUI, but just in case, you might want to check that you do have it in your pip packages. And to get started today, your character should have just docked at Loki Station, and it'll be in one of these random starting locations. So getting into the code, we're going to reuse some of the things that we wrote for our recording bot. We're going to use the playback and the recorder still. And I'm going to create a new folder for today's bot. I'll call it image bot. And we could do some fancy importing to just import this playback and this recorder script. But to keep things simple and keep them separated out, I'm just going to go ahead and copy the playback and recorder scripts into the image bot folder. And in the playback script, we're just going to use this as a library for the functions that it has, so we don't actually need any of the main stuff anymore because we're not going to run this file. So I'll go ahead and delete all that. And then for our recorder script, we still need the folder for our recordings to go into. So I'll go ahead and create that. And our new code today, I'm going to put it in a file called controller. And in our controller, this is going to be the file that we're going to run, and it'll basically just control which actions we're going to play back under which circumstances. So to write our controller script, I'm just going to borrow the main syntax. In our recorder script, we do want to maintain the main calls because we are going to continue to run our recorder script to record each one of the actions that we still need. And then in our controller script, I still want to initialize PyAutoGUI and then give us our countdown timer. I'm going to use these from the playback script, so I can just call them easily enough, and then I'll need to import those from playback. I can import the initialize PyAutoGUI and the countdown timer. And let's add our done print statement. And before we write any more code, let's just outline what exactly it is we want to try to accomplish here. So first we want to start docked at Loki station. And from there, what we want to do is we want to get to our universal starting position. And then once we're in our universal starting position, we can just play back those 4 steps to get to the trader. Go to the trader, do the buying and selling, go back to the ship, and finally fly to Earth Station. And once we're docked at Earth Station, now docked at Earth Station, get to that starting position. And once we've accomplished that, we can just play back our 4 steps for Earth Station, going to the trader, and buying, selling, going back to the ship, and then flying back to Loki Station. And once we've accomplished those things, that'll be a completed loop. Let's even print that out. And once we've completed an entire loop, totally automated, then we can just run that loop again and keep running it over and over again. So now that we've planned out our logic, all we have to do is fill in the steps. So let's fill in first the part that we already know how to do. So we want to play our actions here. And then between each action, we still want to sleep. And of course, to be able to call play actions, we need to import it from playback, play actions. And then we also need to import sleep from time, import sleep. And then we'll have a similar set of actions when we're doing the trading at Earth Station. And when we get all this working, after we finish one loop, we want to go through and do another loop. So let's just go ahead and put that in a loop right now. Let's start it off with 3 times through the entire trading loop. So now the only other parts we have to fill in are these parts where we first dock at a station and we need to get to our universal starting position for that station. So we don't have the code written for this yet, but let's go ahead and fill in this part of our main function as if we had that done. So we're going to get some sort of identifier about what the starting position is. We'll probably write a function for that. Get starting position. We want to know what location we're at, what station. So Loki. For Loki station, get the starting position. And then based off of what's returned, we want to load a different actions file based off of where we start at. And when we have that, we just want to play those actions. So play actions. Loki station. Start. And then this could be a string that we give it, or maybe I'll just make it an integer. So starting position, get starting position is going to return an integer. And that'll indicate which one of our starting positions action scripts we should run. And then we still need to sleep afterwards. So let's make note of what we want to do. Get starting position should return an integer that indicates, or I should say that corresponds with which action, recorded action script, let's call it that, recorded action script should be played. And then we should have a very similar situation for when we land at Earth Station. We need to get from there to that starting location. And we'll just look up Earth instead of Loki for the station we're at. And we'll load a file called Earth Station Start 1, 2, 3, 4, something like that. And then let's go ahead and create the stub for this new function, get starting position. Station. And that's where the code's going to go that will return which of the actions we should run. And then one final piece we're missing is we need to sleep one more time. When we go from Loki Station to Earth Station, when we dock at Earth Station, there's going to be a pause while the station is loading. We don't want to immediately start searching for what location we're in, so let's add a sleep here to account for that. And then we're going to have a similar situation when our loop comes back around and we're docking at Loki Station. But we don't want to wait 10 seconds the first time it goes through the loop though. So only if I is greater than 0 do we want to add that extra 10 seconds of sleep. So the first time it goes through the loop, we'll ignore that part. Okay, so we've got the logic for our script all written out. All we need to do now is write this get starting position function. So before we start to go crazy with writing the logic in here, let's just test to make sure that we can find at least one image inside of the screenshot. So to do this, image position equals PyAutoGUI. It has a function called locate on screen. And you give it an image file, and it'll search your entire screen for this smaller image to see if it can find it anywhere on the screen. And if it does find it, it'll return the position. And if it doesn't, it should return none. So these needle images that we're searching for, we'll have to create these. And in our case, we'll just create them manually. And let's make a folder to hold them. Let's call that images. Maybe needles. And for now, let's just look up one image to see if we can find it on the screen. So I'm going to borrow the code for opening a file. We don't actually need to open it though. We can just pass it the file path. So from our controller script directory, we then want to look in the needles folder. And then we'll call our first one test image 1. I think it'll be a PNG. And then let's adjust our variable names here. I guess needle path would be a little better. So we're going to pass in that path to locate on screen. Let's print out to see what we get. And when we run the controller, we don't want to run through all of our steps yet. We really just want to run this get starting position function. So I'll go up to the top. We'll do the timer still. And then we can just exit the script from that point after it runs. But before we run it, we'll need to create our needle image that we're going to search for. So I'll open up the game here, and all I'm going to do is I'm going to take a screenshot using the screenshot button on my keyboard. Open up Paint, paste the image, and then you want to crop some section out of this image that will always be there whenever you begin in this starting location. So for example, that would be a bad crop because Loudon McEwen likes to move around a little bit. I find that stuff up near the top here is a good area to pick because it doesn't change. You know, down lower here, you have to worry about other players being present and potentially messing you up. And if you make your cropped image very large, that increases the chances that it'll be different between each time you land at the station, because it's going to check every single little pixel inside your image and it needs to match exactly. So you want to keep it small, but you don't want to keep it so small that something's really tiny like that where it's just black in the background, because it's going to find that that needle in your screenshot haystack. It's going to find that all the time for lots of different starting positions. So then you're going to get lots of false positives, and that's problematic as well. So I find something sort of a size like 30 pixels by 10 pixels works pretty good. Something that has at least a couple different colors in it. So for this starting position, something like that. And I'm just going to crop it. And then I'm going to save it. So save it to our needles folder. And what did I call this file? Test image 1. And I decided to use PNG here because that's what the PyAutoGUI documentation uses. You do need to be careful not to use a format that is going to compress, because that compression changes the colors of the pixels a little bit, and that'll throw it off, and it'll say that it can't find your needle, even though it looks like it should be there. So I saved that. I now have that file in my needles folder. Let's go ahead and run this. And then make sure our game is open. Let's see if it finds that exact needle image anywhere on my screen. So they're finished. And need to give the starting position argument station. That makes sense. It's a non-optional parameter. We'll just say it's Loki. I believe we also forgot to import PyAutoGUI. And we also forgot to import OS for opening up that file. So that should be all we need. Let's give it another try. Did it finish? It did. Okay, so we returned a value there. That is exactly what we were hoping for. So that means that it successfully found that needle somewhere on that screen. So you saw me just create the needle image using the print screen button on my keyboard and just pasting it into Paint and cropping it from there. But this might not always line up perfectly with PyAutoGUI. I haven't found any issue with it, but if you do and you're curious to see exactly what PyAutoGUI is seeing, it does have this screenshot function where you pass in the file path of where it should write out the screenshot image, and then it'll also return the image viewed. And this is just another way to create those screenshots that you could crop from. And it's a handy thing to know if you're debugging and you want to see exactly what PyAutoGUI is seeing. But for the rest of this video, I'm not going to use this. I'm just going to continue to manually create the screenshots. So now that we've convinced ourselves that locate on screen is working, let's go ahead and fill in more of this logic for getting the starting position. So if the station is Loki, let's make a list of images to check. They'll have names like Loki station start 1 PNG. What if the station is Earth? It's going to have a different list of images to check. And I decided to use these lists so that you can name these needle files however you want, whichever way makes sense to you. I'm going to end up using just like Loki station start 1, 2, 3, 4, 5, 6, 7. I just found that an easy way to go through it and make these really quickly, because you're going to end up with a lot of these, like 15 to 20 for each station. And then once we have our list of images, we're going to loop through each one of them and check them to see which one we find on the screen. So loop over images till one is found, then return the index, because remember we wanted to return an integer from this starting position that'll correspond to one of our recordings. So return the index of the found image. So I know I want to return the index, so it's going to use an enumeration for index, and we're looping over images to check. Oh, but that's what we're looping over. What should we call it? I guess each one of these is an image file name. We're looping over images to check. And in order to get this index, we need to wrap this in the enumeration. For each one of these images, we want to check to see if we can locate it on the screen. And when we do, it'll be not none. And then in that case, when we find it, we just want to return the index. And I'm actually going to return the index plus 1 so that like the first loop returns 1 and not 0, and so on. So that'll line up well with our naming scheme over here for our images. So like the start 1 image for Loki Station will line up with the Loki Station start 1 JSON file actions. And then if we loop through all of our cropped images and we can't find any of them on the screen, let's go ahead and specify that we're returning none. So get starting position will return none in that case. And when that happens, it'll try to load location start none. And as long as we don't have that file in our recordings, it'll just throw an exception and stop our script. And I think that's good enough for now. So back at the top of our main function, let's go ahead and get rid of this debugging code. We know that get starting position was searching the images fine. So what's going to happen now is we're going to go through our countdown timer. It's going to enter the loop, and it's going to search for the starting position in Loki station. So it's going to go through our needle images that we have listed here, and if it can find it on the screen somewhere, it'll return. So if it finds number 1, it'll return 1. While we have more images, it'll return 2, 3, 4. Whichever one it found, that'll come back up and it'll pass into here, and then it'll try to run this action script. We don't have this action script created yet, but if I run our controller, we should at least see an error that indicates that it can't find this file. So let's see if we can get it to that point. Name error, enumeration not defined. Did I spell it wrong? Let's see where else I've used it. Oh, I know. It's not enumeration. It's just enumerate, isn't it? Let's have another go. Images to checked, reference before assignment. So that means it didn't enter any of these ifs. I bet I didn't capitalize. Yeah, that's lowercase, that's lowercase. So down here, these should also be lowercase. Just your typical script debugging sort of stuff happening. And this time it couldn't find our image, and it's looking for Loki station start1.png, but of course all we have is this test image 1 PNG. Well, I know this test image aligns with our starting position here, so I'll just go ahead and rename it this time. And I'm getting a little annoyed how long it's taking to run our countdown timer. Let's just go ahead and adjust that. So it's doing 10 seconds. I think 6 seconds is more than enough time for me to select that screen. And let's run it again. Okay, and now we have the error that we were expecting. So it returned 1, and now it's trying to load location start1.json to play those actions, but we don't have that recording yet. So what we can do is we can go ahead and record those actions now. So I'll copy that expected file name, go to the recorder, in the output file name, go ahead and paste that. And then just like before, I'm going to run the recorder. Open the game, and now I just need to record how do I get from this initial starting location inside the station to our universal starting location. So in this case, it'll be a pretty simple set of actions. I'll just turn left here, run along the wall, maybe turn towards him a little bit, click on Loudon, close it up, hit escape to stop our recording. And now inside our recordings folder, we have this new actions file. And just like before, I'll manually remove the click. I'll manually remove the escape key, and that's going to get annoying as well because we need to make a lot of these. So I'm going to go into the recorder and modify the code so it doesn't save that escape key anymore. So inside record event here, just going to say if the string of the button equals that key.escape, I'm just going to return so I don't actually record that event. Okay, so you'll notice back in the game, we're no longer at the position we were at when we first landed in the station. So unfortunately, there's no easy way to test if our image recognition and then running of that action works correctly. So what we're going to need to do is we just need to go exit the station, re-land at it, and we'll probably end up in a different starting location. So I'll create a screenshot and crop an image for that needle from that position. Then I'll create a new recording, and then I'll just do that over and over until we start getting some repeats and we start seeing our character actually run through the actions because it recognizes where it started at. So I'll run through that whole process with you one more time. We just landed at this station. I'm going to create a screenshot. I'm going to open Paint, paste it, and I'm going to search for some pixels to capture for our needle image. I'm pretty sure this lighting here doesn't change. That's a good, unique set of pixels, I feel like. Then I'll simply save this as the second possible starting location. I'll need to update the getStartingPosition function to now look for this image. And then what I can do is I can run the controller just to make sure that it is finding that needle on the current screen. And of course, when you're doing all this, be very careful not to accidentally move your character at all because it'll throw the whole thing off. It completed, and yeah, it's looking for that second JSON file now. So that means that it found it correctly. So then I'm going to go to my recorder, update the output file name to the start location number 2, and then I'll begin recording this action. And in the game, I'll just take a series of actions to get to our position next to Loudon McEwen. Once that's done, I'll open up the new recording. Well, that's the image file. The recording number 2. I'll get rid of those first couple of clicks to select the screen. Let's see if it correctly left off the escape key, and it did, so we don't have to worry about that in the future. And that's everything we need to do to set up our second starting location. So then we'll just go back, exit the station again, we'll come back in, and we'll do it all over again. So I spent an hour or two going through and making all of the cropped images and all of the recordings for all the possible starting locations, both at Loki Station, and I went over and docked at Earth Station and made a bunch of needles and recorded actions for there as well. So I'll save you the boredom of watching me do all that. But you can see I've got all my recording files in here. And then I've also got all of the different images that I'm trying to find to figure out where we're starting in a station. And then in my recordings, I also went ahead and copied over the go to trader, go to ship, all the sections in these actions that we did in the recorder video. So from that last video in this series, you should already have all of the Earth Station steps for going to the trader, doing the trading, going back, then flying over to Loki Station. And then if you did the suggested homework in that video, you'll also have those for Loki Station. If you don't have those yet, you can go and create those at Loki Station as well. So as you're creating these needle images and your recordings, if you're going through and running your controller each time that you re-land at the station, you'll eventually start to notice once you get to 5 or 6 that it actually does recognize where you landed, and it should start running through your actions. And then if you've copied over the actions for the rest of the script, go into the trader, doing the trading, going back, it should run all of those now. So it probably takes, you need to get 5 or 6 of these first. Definitely by the time you get to, 10 or 12, you should be starting to see, 50% of the time or more you land at the station, it recognizes where you're at and it starts running through your actions. So let me show you what that looks like when that happens successfully. So you will notice that as your list of images gets longer and longer, it does take longer and longer to recognize which location you're at. The PyAutoGUI locate on screen function is a little bit slow, and so as you're running it more and more times, it does take a while to recognize where you're beginning at. So in this instance, it didn't find where I started at, so this would be a good opportunity for me to once again take a screenshot and go through my process of recording my actions. There, we've got one that was recognized. So this is interesting. I made these recordings yesterday using a different character that I've been using for testing. And this character seems to work alright, but when I used the other character I was showing you, it was not recognizing any of the needles that we were searching for. It makes me think that maybe because the characters are 2 different heights, just the height of the character is changing the camera position slightly, which is making the images that work for this character not work at all for the other character that I have that's slightly shorter. So the images that I have in the GitHub repo might not work for you exactly unless your character is also the same height as mine. So what I'd like to do now is just clean up our code a little bit. Instead of throwing that exception error if it can't find the action file or if it can't find the position, let's throw just a little nicer errors. We'll just print out nicer errors and just exit our script. So I'll throw this in a try except. File not found error. If that happens, I might even want that error message. Let's print out, well, I would say if the starting position, or if not starting position, so if we didn't find a starting position, that should be one error. Starting position not recognized in Loki. But if we did find a starting position, we just didn't have an action script for that. Let's print out a different error. No, recorded actions for position. This will be like position 1 or 2 or 3 or so on. But if we were able to play it, let's print out something to say that which action we played. So this will help us to identify which one of our actions are working correctly and which ones maybe we need to delete the action file and try it again the next time we start at that position. So we'll say played starting actions So I'd like to print out the name of the JSON file that we ran. So let's update the code up here to save that to the action file name variable. And then we can just play that. Okay, so that'll give us some nicer print statements and error messages. I guess if we do hit this file not found error though, we still want to exit our script because we don't really want to try to continue past that. So I'll just add an exit. The number 0 there says that our script exited successfully. You could put like a 1 there if you wanted it to be an error exit, but this is fine. And now that we've cleaned up the error handling for Loki Station, we can do the same thing for the Earth Station. So here we're getting the starting position for Earth. Still Earth Station for the starting files. Mentioned that we couldn't find the position at Earth Station. The rest of that looks good, so we can remove that older code. And that's that. Okay, and before we finish up this tutorial, I want to teach you one more thing. You'll notice sometimes as you're running through your script that it'll get off. It might just pause, or it might take longer to load or something, and instead of your character running straight to this door, it might run off to the side and then just get stuck or something like that. And if you're running your bot while you're away from your computer, it could be stuck here for 30 minutes, an hour, who knows how long. And what we want to do is we want to be able to detect when this happens, and that way we can just exit our script so that we don't continue to just click and move everywhere in a way that doesn't make sense because our character is so far off. So to do this, I'm going to show you how to check individual pixel values. We can use PyAutoGUI to do this. So for instance, when we get to our starting position here next to Loudy McEwen, there are certain pixels that should always probably be the same. I found some good pixels to check are here on his name, because the name tag, it's always relative to where he is. You don't want to check like his hair color because he's moving around all the time. But like the yellow inside that E is pretty much always going to be at that pixel if you're in the right location. If your character's off, if you're like over here somewhere, then that pixel is not going to be that yellow color. And so we can detect that, and then when that happens, we can throw out an error and stop our script. So to do this, I'm going to write a new function. Let's see here. We're first going through the loop. We get to Loki Station. Hopefully we recognized where we started at, and then we got to our universal starting position. But we can check to see if that happened or not. So let's write a new function called confirm position. And let's just give it a string that says what position we want to check. So we'll say this is Loki Station starting position. And I can go ahead and write a function for that. Position name be the name of that parameter. Okay, so I'm back here on the PyAutoGUI documentation, and I'm looking at this pixel matching section, and it has this PyAutoGUI pixel matches color function available, and it'll just return true if the pixel does match, or false if it doesn't match. And I also noticed that it had this handy tolerance parameter so that we can just find if it almost matches. That'll help us to overcome any errors where the pixel is just slightly off, but we're still actually in the right location. So the way that this function works is this is the X position on the screen, the Y position, and then these are the RGB values, so the red, green, and blue values of that particular pixel. And then the tolerance will let us be off by a certain value. So I think like if you give it 10 here, this means that any one of these values could be plus or minus 10 of what you tell it, and it'll still return true. Otherwise, if it's completely off, it'll return false. So this will be a good way for us to check to make sure that we're on course. So in the game here, I want to check the pixel. Like I said, the yellow inside this E I think is a good standout color for us to check. So what I'm going to do is I'm going to take another screen capture using the print screen button, and then just back in Paint again, it's a handy little program. I'm going to take the color picker tool here, and I'm going to go over to where this E is. I'm going to aim somewhere like in the middle, and then you'll notice down in the lower left hand corner of Paint, it'll tell us the XY position that our mouse is at. So right now I'm at 897 X position and 153 Y position, and then I can click and it'll select the color at that position up above, and then I can click the edit colors, and over here on the right hand panel it'll tell us the RGB values of that color that's selected. So we want to check that coordinate position and match it up with this RGB value, and then give it a bit of a tolerance, and then anytime that pixel is about that color, then we'll return true because we know we're on path. But if it's something totally different, it'll return false, and that'll be a good indication to us that we're off path and we should just stop our script. So back in our code, let's write that in the confirm position function. So if position name is, what did we call this? We're confirming that Loki station starting position. So if that's the position that we want to confirm, then we'll need an X, Y, an RGB, and X, Y equals, those will be our X, Y values. I'll just put something, placeholder in there for now. And then our RGB, this will be a single variable, because we can hold this as a tuple, I suppose. So this will be the R value, G value, and the blue value. These go from 0 to 255, I believe. And then let's actually check our Paint program here and get the real values. So 172, 178, 41. 172, 178, 41. That's the color I picked from where? I believe that was about right there. 898, 153. Then we'll just double check. 898, 153. Grab that color. 172, 178, 41. That's good. Now we want to look for, does the pixel match? So pixel matches equals, we're going to call that PyAutoGUI function. Check the documentation, it was called pixel matches color. Let's just grab that. Alright, so this will be the X value. That's the Y value. This is the RGB. And let's leave that tolerance 10, that sounds alright. So what do we do if the pixel matches? That means we're on course. Not matches means we're not on course. And in this case, let's raise an exception. This will stop our program. Detected off course 4. We'll give it the position name that we checked. And then let's get some debug information. That way we can see if it does detect we're off course, but it looks like we are on course when we're testing this, we'll see what X, Y, and RGB it's looking for. So I'll need to pass in some sort of debug string. So let's make our debug string. We'll say position is something, and then we want to know our RGB of the expected. And then what RGB did we actually found? So we know the position is that XY. We also know the expected RGB. And then what did it actually find? So we can figure this out by calling PyAutoGUI. I believe it's just called pixel, right? Yeah, so if you call pixel, it'll return the RGB value at that location. So here we can just give it the X and the Y. And that'll make for a good debug string. There's also the possibility that we don't recognize the position name that we are looking for. So let's make an else down here. That'll raise an exception also. Just say position to confirm not recognized. So now when we run our script, when it gets to our universal starting location at Loki station, it's going to call this confirm position. If it confirms that we are on track, it's going to just print out. Oh, it's not going to print out. Let's print out something to say we're on track. Let's print on track for position name. So I'll say on track for Loki station starting position. But if it detects that we're off, it'll raise an exception. We'll get this exception message depending on what the problem was. And then by raising that exception, it'll also stop our script. So I'm gonna re-enter Loki station and see if our detection is working properly. I forgot colon. I forgot a parenthesis. Alright, so it recognized our starting location. And now we're going to the universal starting location for Loki station. No hands. Alright. And now we're talking to Loudon to make sure we're oriented correctly, and now it's doing our check, and it said that we're on track. So that's perfect. I'll go ahead and stop the script. We can look at our output to make sure. And there it says on track for Loki station. So it recognized the pixel there. Another good place to check to make sure you're on track is when you're doing your trading. Once you talk to the trader, I've been checking this flag color over here. It's a pretty distinct color you're not likely to find anywhere else. So I'll put that in the code too. I'll do another confirm position on that pixel over there. So to do that, I'll copy that. After we do the trading, so when we're done talking to the character, let's confirm the position, Loki station, done trading. Go down to the function, elif position name is done trading. We'll set up the X and Y's for those. So once again, I'll take a screenshot. Use my dropper. So I'm going to try to get over here 450 by 296. $450, 296. What color can we find there? There's our RGB, 79, 78, 13. Alright, so now we've got another position that we're checking to make sure we're still on track. And then if we're not, it'll go ahead and exit our script. So that about does it for this tutorial. There's obviously a ton of optimizations you can make to this. One that comes to mind right away is when we're searching for what our starting position is inside of a station. That obviously takes a while. What's happening is the PyAutoGUI is taking a screenshot each time when it's comparing those needles. So you might find a way to adjust that so that PyAutoGUI takes just one screenshot and then it searches for all of the needle images inside of it. That might help speed up the process. We also took all of our needle images just from the top few rows of pixels on the screen. So you might also be able to adjust it to just search the top 100 or 200 rows of pixels or so. And that should also speed up the locate on screen process. One other option that's a lot easier that's already built in is that PyAutoGUI has a grayscale option. So it says in the documentation you get about a 30% boost if you turn on the grayscale option. So more likely to find false positives there, but in most cases that's probably a performance boost that'll be worth it and it'll probably still work really well. Also, if you decide to set up more trading routes, I think a lot of these stations are pretty similar. They might even be identical. So it'd be interesting if you could find a way to use one set of needle images and have it work for a bunch of different stations in order to determine your starting location. You'd still need to create different actions for each station, of course, because each one's going to have a different universal starting position that you'll find within it. If you've missed anything, there's a link to the GitHub in the description, and it has all of the source code of everything that I've written here in these videos. And then if you're enjoying Earth and Beyond and you're really enjoying the spot that we're making, there's tons more you could do with it. One big improvement you might make is, if you detect that you're off course, instead of just stopping your script, you might consider having it automatically log out of the game and then log back in. And then hopefully you can detect from there where your starting position is and then pick up where you left off. That way your bot is a lot more resilient. It can withstand hiccups a lot better without you being around to help fix it. So some other things you could do is you could set up a longer, maybe more lucrative trade route. The one that I picked and showed for this tutorial is really a beginner trade route. So there's definitely tons more out there to do. You could also automate travel a lot more in this game. Sometimes in the game you need to move across the galaxy and that can take quite a while. So if you're able to automate something like that, that could save you a lot of headache inside the game. For something more advanced, you could also try automate combat with those guys over there. You could also try automating mining within the game if you're also looking for another way to increase your exploration rank or just make more credits still. And of course, the techniques that I've taught you here can be applied to other games, so I encourage you to explore that as well.
That's all I've got for this tutorial series. I hope you've enjoyed it and that you've learned something new here. And before you go, I've got a quick favor to ask of you. Since I'm just getting started with this YouTube channel, I'd love to hear from you. What am I doing well? What could I do better? What kind of videos do you want to see from me? My goal here is to help more people learn how to code and have fun doing it. The world needs more programmers, and there's no reason why learning how to code shouldn't be a rewarding and joyful experience. So my email is in the description. You can reach me there. I'd also be happy to hop on a Skype or Discord chat with you if you're interested and just talk about coding, or leave a comment below. I know it might seem minor, but hearing from you would really mean a lot to me. So that's it. I've already started working on the next tutorial series. It's going to be about another type of video game botting, probably in Python. So subscribe to get notified when I release that if you haven't already, and I'll see you then. Thanks for watching.